Let's see if we can draw the tank here. So we have the ends of a horizontal tank, 12 meters long, are ellipses. All right, so I have an ellipse on each side. Ends of the tank are ellipses. And then it's 12 meters across. So I think if I'm looking at it from a slight angle in front, it's not a very good ellipse. Try again. I have this elliptical end here, and then I go over 12 meters, and then there's another ellipse on the other end. And let's say we're kind of looking through it there. So I'm standing over here on the left side of it looking at it. So here's elliptical end and elliptical end, and the ellipse has that equation. And then the 12 meters comes across there like that. So we just need to know the dimensions of the ellipse because they tell us the area of an ellipse is pi times AB. And that's considering the standard form of an ellipse centered at the origin, something like x squared over a squared plus y squared over b squared equals 1. So we need to make this ellipse equation look like that one. So if I want to get 1 on the other side here, I would just divide by 80. So we'll take the 4x squared plus 20y squared equals 80. And let's divide everything by 80. And clean it up. So 80 divided by 80 is 1. It's the easy one. 20 goes into 84 times, so that would be y squared over 4. And 4 goes into 80 20 times, so that would be x squared over 20. So then the a squared must be 20. So a has to be the square root of 20. And then the b squared has to be the 4. And square root of 4 is 2, so b would have to be 2. So then the area of this ellipse right here would be pi times a, square root of 20, times b, which is 2. And this is basically like an elliptical cylinder, and anything that has a shape like this, the volume of it is always the area of the base times the height. H-E-I-G-H-T, there we go. So we're going to consider this the base right here, and that the height perpendicular to it. So then my volume is going to be that area, pi square root of 20 times 2, and that would be meters times meters. So that's a meter squared times the height of this thing, which is the 12, and that's meters. So altogether I get meters cubed, whatever that number right there is, which we can just whip out on a calculator. Let's try that. So we had pi times the square root of 20 times 2 times that 12. So let's go to 2 decimal places for the heck of it. So 337.19. So this right here is approximately 337.19 meters cubed. And there's a note here that says, hey, the second box is for the units. So I would say 337.19 meters raised to the third power. Nice job.